Hi everyone! In this short video, I'm going to show you how virtualization can help us with cross-platform development. When you write cross-platform code like this one, you basically implement some universal methods or classes that are platform independent. But inside them, you usually write separate code for each platform you want to support and use these macros -if, -else, and if, and so on, to specify which code to use for which platform. When your code is ready, you have to check and test it, and you need to have some approach to do it for every supported platform. I think using virtual machine can help us here a lot, and in the video I will show you how I used native macOS approach for my cross-platform development. I'm going to use Virtualization.framework, which is available from 11th version of macOS. See the link in the description. Compared to other solutions, especially proprietary, it has some important advantages. First, it's free, and second, it's built in macOS system. So your virtual machine consists of literally one executable file, an image of another operation system. As disadvantages, I can mention necessity of implementation any additional functionality you need. But luckily almost all you need is already done for you. You will hardly have to write anything yourself. Okay, now let's define what I need to have for my cross-platform development. As host machine, I'm going to use MacBook on M chip with macOS, and Xcode as a common instrument to write code. Here I will write and test my code for Apple platforms. As additional platform I want to support, I selected Linux. In particular, it will be Ubuntu distribution. So my virtual machine will have installed Ubuntu system plus Visual Studio Code. This virtual machine will have a direct access to my project folder on the host I'm working on. And as a result, I can test my code simultaneously for Apple and Linux platforms. To reach this goal, I will perform the next steps. At the beginning, I will create and set up a virtual machine. For this, I will download the project of virtual machine for Linux platform from Apple developer site. Then, I will add an ability to use shared folders to it. Next, I will download and install Ubuntu on my virtual machine. After this, I will set up shared folders for auto-mounting on Ubuntu on startup. Install Swift and Visual Studio Code will be the final step here. When all of the above is ready, I can start writing the code. For demo purpose, I will create a new Swift package. I will write code for Apple platform first and test it. And then I will do the same for Linux using virtual machine. Testing is crucial part here. It's important to note that I will have the same test for all platforms. It guarantees that my cross-platform code works properly between all platforms. Let's start. First of all, I'm downloading the Xcode project from Apple Developer Portal. See the attached link in the description. I will make some changes in it. Let's provide a team. I don't want to use this long name, so I'm going to change it to some shorter, like Ubuntu. As you can see, there is only one file with source code, and I'll add some changes here as well. Here is a link to bundle path. Right now it's static and point to some path in home directory. I want to make it more dynamic, so my app will search for appropriate bundle in the same directory where this application is being running. For my purpose, 64 GB disk space is too much. I change it to 16. it will be enough. 4 GB of RAM is okay. Finally, let's write some code for working with shared folders. I want to share an access with two directories on my Mac, Downloads and Dev. To do it, I use the following code. Here I provide two URLs in my Mac system I want to share with my virtual machine. Next, I make them editable from my virtual machine. Here I select names which this folder will have. At the end, I create and return sharing configuration. Below, I use my method while creating virtual machine configuration. Finally, I add app icon to make the app a bit more attractive. Before I build the app, let's change build sham to use release configuration, so my app will be more performed. Let's build the project. Cool, it's done. Now I copy the build to special folder for my virtual machine named Ubuntu. I will use it a bit later. Now I have to download Ubuntu distribution. I need this one for ARM architecture. I will add the link where you can find this build. The image is downloaded and I can run now my virtual machine to install Ubuntu. I will speed up some parts of the installation process. Let's change the screen resolution. I'm using default preference everywhere. Roman will be my username and Ubuntu is my computer name. For brevity, I use weak password. The operation system is installed and now it's time to restart it. Let's change the screen resolution and path through the initial setup. Also, I'm removing all elements I don't need on my home screen and pin terminal here. Now, to mount my shared folders, I have to do the following steps. First, I need to create a shared folder in my home directory. Next, I execute in terminal the following command. Shared here is a tag from my system device configuration. And the last path is full path of folder of virtual machine I just created. As you can see now, I have direct write access to my host machine file system. But I must execute this command every time the virtual machine is starting. So, let's put the command in a script file and ask my system to launch the script automatically. But before, let's pin my folders to bookmarks. Now I'm creating a bash file which I will use several times further. I put the following commands inside it with detailed description what they do. You can find it in the description. If you're familiar with Linux, I think there is nothing special for you. In terminal, I call the following command. So the script will have appropriate permission when executed. And now I just execute the script. Let's restart the system and see how it works. As you can see, my folders are mounted, but for some reason my common shared folder doesn't work. I don't know why it breaks, but if you know how to avoid this error, please write at comments below. But for me, it's not crucial right now, because I have an access to my working folders. So let's install Swift next. I'm updating my install bash file with new commands, which you also can find in the description, and run it again. Please note that I installed two additional libs, OpenSSL and libssl-dev. They will be needed later as dependency in my demo project. In general, there is installation described on Swift's official site. I just made a final script for it. Let's save and run it again. But now I should run the script as super user. Please note that Swift was installed to root directory. Now I need to restart my virtual machine again. Let's check Swift is installed properly. And finally, let's install Visual Studio Code. Don't forget, I work with IRM architecture. To install, I use a command. In Visual Studio Code, let's install necessary extension to work with Swift. Now, to demonstrate how I'm going to work with all these environments, I will create a Swift module which will provide me an ability of generation random bytes. But I don't want it be just random bytes. I want it to be cryptographically strong random bytes suitable for use as cryptographic keys. And of course, this package will be support Apple and Linux platforms. So let's create a new Swift package named RandomBytes. Let's edit package file a bit. 6th version will be enough to me. Then I'm going to write the code itself. On Apple platforms, I'm going to use Common Crypto Framework. On Linux, I will use OpenSSL library and will write appropriate code later. Now I'm going to add error type. For brevity, I don't want to spend a lot of time on error handler here, so I will just use a simple error type. But I encourage you to not do so in a real project. You must always handle your errors gracefully. Next, I add a method body to generate random bytes. Finally, let's add auxiliary extension to work with this method. In conclusion, I am adding two test methods to check my code works properly. In the first method, I want to check that random bytes differ from 0 bytes. In the second method, I generate two arrays of random bytes in a loop and compare them with each other as well as with random bytes from previous iteration. Okay, everything looks perfect. And now I'm ready to switch on implementation for Linux platform. As you remember, I'm going to use OpenSSL library here. So before I can implement necessary code in my package, I have to create another one to import OpenSSL to my project. So let's create a new package named OpenSSL. Let's init a new Swift package. Then I'm removing test folder. I don't need it because this package is literally system library. I also delete OpenSSL file and create two another files. First is module map, which contains these lines of code, and shim header file, which contains included OpenSSL header files. I'm updating package file as well, so it has system library target. Now OpenSSL package is ready and I can import it to my main package. Again, I'm changing package file. So when built for Linux, it has to import OpenSSL package. Now I can import OpenSSL library. According to documentation, I can use RandomBytes method from OpenSSL library to generate cryptographically strong random bytes. As you can see, there is nothing special here, and I'm ready to test my code on Linux. My tests are passed. Let's move back to macOS and check I didn't break anything while I was implementing code for Linux platform. I see new code here. Well, everything looks great, and my package for generation cryptographically strong random bytes is ready to use on Apple and Linux platforms. For today that's all. If you found this video useful, please press like button and subscribe to my channel. Bye.